So I'm going to mute everyone. Okay, you can ask your questions after the first session. So today, as I know, there are a few people they requested that we'll go through some of the Wireshark options. So we will go through the Wireshark options, and then we will talk about the lab today. We're going to talk about the lab and Wireshark options. Then followed by that, we have a lab for MTU field in the IP header. We got IP MTU and Ethernet MTU. We got layer 2 MTU and layer 3 MTU. And then we'll look into the TCP header values. And the TTL is most important. So if we have a time, we'll continue with the TTL lab. And also the final lab is your path MTU discovery. So first we'll understand what is an MTU, how it works within the lab. Then we will do a lab for the external, and I'll try to discover the MTU size of a specific destination. So that's the whole idea of today's training. So let me start with this. So Wireshark lab. Let's start with Wireshark lab. I will send out a link where you can follow the video. It's pretty straightforward. You can use it. Here you can, I think in the link, you will get some kind of a Windows server or Windows 7 computer image you will get. There you can use your browsers to simulate some HTTP traffic. So that's running on top of TCP. So we will do the testing with that. And also you can do a command prompt pings. If you want to do a telnet testing for TCP, you can do that in the Windows server. So the very minimum configuration, I would say 16 would be very good. 32 is great, but the 16 would be fine. 16 GB RAM, and I think a pretty decent processor like i5 or i3 processor with a good Windows computer, and a minimum 250 GB hard drive is sufficient for this. Maybe this you have to run EVNG software. That's a freeware you get. On top of that, I will share the image where you can watch the videos and also the link to download the images to upload those images for your devices. So for just for a ping trace routes, you can use this VPC device. You can once you this is a default. You don't want to install this. This is virtual PCs where you can assign an IP address and you can do your testing for layer 2 connection, for your layer 3 testing, for even if you want to do some IP packets, you can do that. And mostly I'll be using in the future classes also, it would be helpful. So I mean, I would suggest at least one firewall connected to the switch and one router, maybe a couple of routers and one computer. So altogether, 1, 2, 3, 4, 5, 6 devices maximum. It's a maximum setting. So you can even get rid of this router 1, 2, 3, 4, 5. Maybe 5 to 4 devices is sufficient for this. And you have an option. I mean, the Wireshark is integrated in the EVNG. So whenever you want to do a capture, you have to do a right click on a device and go to a capture option in the corner. There you will see the list of interfaces. Say, for example, if I'm interested to capture the traffic on GA1/3, which goes to the VPC, you can do it straight away. And I would say when you look for the layer 2 packets, example, if you want to see is it my VLANs or tagged properly on a specific ports, it's always recommended to do it on the switch and not on the PC. And most of the time you don't get it. You have to do it from the switch standpoint when you're doing that for your VLANs, I would say. Then models. I mean, one Palo Alto would be the 8.x, the older version still you get. That's very, you need a very less compute to run it. You don't need a very powerful RAM. I mean, you don't need more RAM to run it. So the compute is very less. So you can prefer the older images or better for your compute. And if you have a good hardware resources, you can use PanaOS 10 as per your need and the computers. Yeah. That's really about the lab. So I'll share the link and we'll do that. So Wireshark is integrated. On top of that, you can also use your computer and you can install the Wireshark in your computer. That's again a freeware. You will get a Wireshark. You have to go to 1 minute. So you can download your Wireshark from this website. You can download. So this gives you the latest version of Wireshark, and it is free. It's a freeware, like your Linux. It's a freeware. You don't want to pay anything, any subscription. All you have to do is go to the download, and there you can download your exe files and you can do your installation. That's how it works for it. And then what else? I mean, this are all the basic requirements I've told you. This is all something you need to build your lab. Not a big thing. Even you will get the images, you know that in the internet you will get the images. We will also share the link to download the lab. Go through the lab, and I think it's pretty straightforward to do it. It's not very difficult to do that. And still, if you're experiencing any problem, you're always free to send messages in WhatsApp group where you guys you have to help each other, because there's some people they would have used a lab for different technologies like um, Hemos, Palo Alto, or maybe F5 for with it. So you guys were experienced with that. Also, no problem. You can always feel free to what is that? Put your questions in the WhatsApp chats. So we can help each other. And also, if not, I mean, yeah, definitely I'll jump in and help you out. That's really about the lab, and we don't need much apart from this, because we can simulate this traffic whatever we want. And one more thing I want to tell you, and when you're doing the lab, if possible, not if possible, I would suggest you connect to this cloud connection. I think you have to go to the node. Where is it? Network, yeah. So when you right click on the EVNG, you'll get an option network. There, the option what I have chosen here is a bridge. So when what happens here, it bridges your connection directly to your internet. You can do that. So this connects directly to the internet. I'll show you that. Is So if you see this, I got this IP address as a DHCP IP address from this outside interface. I mean, from the same thing from your when you connect to your internet, you will get a connection back, and from this you can access all your public IPs. My public IP is reachable from this box. So this is how it works. So you can connect a device and you can do an ad translation on the egress interface GI0/1 in a router. So that helps you to simulate some kind of traffic if you want to capture something from your server or a computer. for if you want to simulate some traffic with any external IPs, you can also do that. We will be doing that in the lab as well. But that's it. I mean, it's a very simple topology. We might be stick to the same topology. Maybe some modifications needed as per the course content. We will make some changes in the future, but mostly we will be stick to the same kind of lab setup. No much changes with that. Just 4 or 5 devices and more with Wireshark. So coming back to Wireshark, let me open up this Wireshark. So once you finish installing the Wireshark, you'll get an option like this. So here, if you see, I'm connected to the Wi-Fi, and you can see this. I mean, the traffic logs here. The signals goes up and down here, so it means that there are some traffic going on with the specific interfaces. So I am connected to Wi-Fi. So if you're connected to LAN, it's something your LAN should show this connection, the graph. So all I have to do is I have to double click, right click. Then it starts capturing all your traffic that's been going on this wireless NIC. So the options, what we should focus on much, sometimes what happens, this is automatically scrolls to the lost package during a live capture. So what happens here when it is keep running, right? So it'll go automatically to the bottom of the line. You don't want to go to the bottom of the line. So it keeps, automatically it scrolls to the last packet during a live capture. That's very helpful. You have to enable this. I think by default it would be enabled. And this is a coloring rule. We'll discuss about that. What is coloring rule? How to do that? Yeah, I'll show you. And the most important options, how I should create my profile. So we'll talk about how to create a profiles and everything in the future. So the basic settings, I'm telling you the very basic settings, what we should do is the very first thing is here, the time option here is very, very important in Wireshark when you're capturing it. And especially it helps for your round trip time. Yeah, so you should always go to view, time display format, always go for seconds since previously displayed packet. Don't choose any other options. Go to the time and display format. It is, I mean, you have that option below the view option. Then go back to time display format, and there is an option seconds since previously displayed packet. So what it does, time seconds since previously displayed packet. I mean, if I look for these two packets, let's take I don't see any SYN packet here. Let's see, it's two pack. Don't see SYN. Let me open new capture for you with SYN. Packets with SYN. It's just loading now. Pretty big file. Okay. So where is SYN? Okay. So you should always what is that? So close this. What I was talking about. Okay. So if you look at this, the layouts, what we are discussing now, the very key important fields, and I'm talking about this RTT, right? So when you go for this a conversation filter, and if I do a TCP, then Synac, I'm looking for a packet from SYN. Edit preferences. If I go for coloring rule, I think these are all the defaults you would see, I believe, or else where you have to go, I'll tell you. You have to go to view. That's not happening for me. Something is stopping me to do this. Hmm, okay, here, okay, this failed. If you go to view and you got your coloring rules, time format, view, time formats, seconds since previously displayed packet. So this is a coloring rule. I'll come back to the time display format, why it is important. So if you go to the coloring rules, I think these are all the defaults, or else in the coloring rules, you can add if something is missing. I hope I didn't do any changes here. Uh, if not, guys, let me know what is missing here. Yeah. If you go to this, pretty straightforward. All you can see all this coloring rules. That's all predefined coloring rules. So the BAT TCP is TCP dot analysis flag. If you type even, I'll show you how to type it. Then this TCP SYN equal to TCP dot flag dot SYN equal to 1. It means that whenever I see a packet, and if it is a SYN packet, it just gives a color green to them. So all my SYN packets will be highlighted with green. So that's the meaning of it. You can choose your own colors, but I always prefer green for SYN because it's successful. And the red packets, this is all for the resets. Whenever you see a resets, you can see all this red color packets coming in for the TCP resets. And ARP shows up with this light yellow color. It's all predefined. If you want to change your colors, you can go ahead and change your color here. If you click on this, you can choose your colors here and you can change. Well, whatever colors you want, you can pick the colors. And once you click OK, you are giving your colors to the filters. That's custom colors, whatever you want, you can give. So the main thing what we should see is TCP flags and bad packets for the beginning. In the future, if something we need, we can add. This is called coloring rules. You can add your coloring rules. And the filters, I'll give you the filters. What are the filters I use? In the document, I'll keep frequently, I'll update all the filters. So you can follow accordingly the filters. So since I said this is a SYN packet, you see the color green because of the coloring rule, what we made there. And here, the time since the previously displayed packet. So what happens here? Let me take a whiteboard for it to explain better how this works. Very bottom of this page. Okay. Draw, take a pen. Yep. One second. So I got a packet one. I mean, we are not discussing much about anything here. Here, I'm talking about the logics of the time format. So this is a packet. This is called a TCP SYN. This comes back from the server, SYN ACK, right? This is a server, and this is a client. So what, I mean, if I do time since the previously displayed packet, I mean, it captures the time right from here to the next packet, right? So I started maybe from 0. So it reached the server, the packet reached the server from the client, and it's coming back. Maybe it says 236 millisecond. So especially in networking, when we are talking about the times, right? So time is very crucial. And if it is exceeding more than milliseconds, it's a problem. Example, have you seen a connection with 6 seconds? It's terribly bad connection, terribly slow connection. So mostly it happens within the milliseconds. Sometimes it depends on the user request. It may go somewhere around 1 seconds, 2 seconds. So I'm not telling you you can't see it, but that's again a bad connection. You will definitely experience a slowness if it jumps more than 3 seconds. That's too much, too long waiting in the network. So when I say the displayed the previously time since the previously displayed packet, so the meaning is you start with 0, so it's coming back in 236 milliseconds. So whenever even your troubleshooting, right, the very first packet you should see is your round trip time. We call this as a RTT. So when you have your flight and it's going, and I mean, while you do a booking, it asks for your round trip booking, back and forth, right, from source to destination and destination to source. So what is the time taken for this? That is your RTT. From source to destination and destination back to source. How long it took? Maybe 236 milliseconds when we start with 0. That's your RTT. Let me go back to this. So here RTT is 211 milliseconds. So what are the key values you should see here when you see for, since in ACK yesterday we discussed, and this is the server. It sends a SYN for this because this is a public IP address, right? So this is a private IP address. And yesterday we talked about the IP headers, yeah, little bit, but today we are doing a little more deeper about IP packets, all this. But now coming back to the filter then. So SYN is marked with this color green. This is SYN ACK. This is all this acts, or I think it's in a blue color. And you can see this black color packets. Sorry, yeah, black color packets. It's your bad packets. Also, how do you filter those packets? TCP dot analysis dot flags. Analysis dot flags. So it will show you all your bad packets, uh, your duplicate acknowledgement. So we will see this everything in the upcoming training. We will discuss about this, but I'm telling this all your bad packets. You should not see this much packets here. So out of 21,000 packets, you see somewhere around 76,637 packets. It's almost 36% of bad packets here. So whenever you're doing something, you should focus on this field. Can I take a pen to highlight this? So whatever the filter I have applied here, it says total packets and the displayed packets based on the filter what I have given here. It's 36% bad packets here. And the option at the very bottom, if you see, this is the very bottom, right? So this option is called expert info. If I hover over this, I should see. This is called Wireshark expert information. So based on the coloring rule, you can see here. So right away, it's like a one, you got it's like a single pane of glass. You see all your TCP conversation. It's a good connection, bad connection, everything. You get everything, but that's properly, what do you say, properly aggregated based on the protocols. And if you want to look only for your TCP zero window size TCP problem, this is a window you can see. See, TCP window specified by the receiver is now completely full. So if you want to see that, you can see that this is all the TCP full messages you got. So this helps a lot for your troubleshooting. Instead of just scrolling back with the packets here, if you know this key components, this is a selective acknowledgement. We'll discuss about that, but we are just discussing about the options. So everything is properly aggregated. Duplicate acknowledgements is all your fin packets. So expert info, time format, coloring rule. Then this is, I think, what is that? This is, you get this context help. When you just type IP dot, I don't want to type the full command. IP dot address. If this all cached, and if you want to change the IP, just click on it. 10.0.0. Sorry, it's 8.8.8. And if you want to do capture for bidirectionally from the source and destination, example, my address is address equal 192.168.0.1. I can do that. And if you have a proper filter here, only then you see green color, and it will process your packet when you hit enter here in the bottom. And if you see this profile, I'm using a default profile, but in the future, if you want to add any profiles, you have to do a profile. So that's something we will see later, not now. And about TCP, you can just type TCP. That will show you only the TCP conversations. But you see for all. And if you want to see a TCP connection only for a specific IP address, how to do that? So it's IP dot address equal 8.8.8.8. So now there is no traffic for it. So we don't see anything. And what more useful, that's something I think they made some changes in the Wireshark. So if you want to look for DNS, a specific name, DNS matches, example, google.com. It should be DNS matches, double colon, and the keyword. Example, if I want to search for google.com, colon enter. No packet for google.com. So if I do for a DNS, kind of DNS I see here, youtube.com. Okay. DNS matches YouTube. So if I type this, you can just focus on your DNS conversation. So, and this arrow marks you have to focus on this is going from source, the arrow marks going outwards, and this is an outbound and this is an inbound connection. So this is my query and this is my query response. Like for your SYN, you see your SYN ACK. Three-way handshake, there is no options to show something like that. But this is a query and this is a query response. You can see like this. And let's take one single packet. Let's take this packet. So when you see from every layer, right? So it's very straightforward. Let me take this pen. We are going from layer 2. Yeah. Here you in the options here, you can't see anything what is inside this frame 1. We don't care because this is purely a layer 1, right? So we start looking at the packets from layer 2. And I'll tell you one more thing. You don't what is that? You don't make any judgments for your checksum values because all your packets that flows in the wire, Wireshark is capturing this logs before the NIC, right? You got it. I mean, I'm capturing this traffic, everything before this particular traffic leaves my NIC card. So your checksum is not applicable anytime. It's not recommended to verify your checksum. Layer 2 and layer 3 checksum, there is a field. If your packet is tampered in the middle or something happened, that's again, it's a drop packet, right? So you can't do any analysis based on your checksum in Wireshark. That's not recommended. That's one disclaimer I would like to say. So you just remove your checksum analysis with irrespective of layer 3 and layer 2 in if you see this validation is disabled for your checksum. You don't want to see the checksum value here. So when you come to this Ethernet 2, uh, the main thing what you should focus here actually you can see your source MAC address and the destination MAC address. Right, this is my computer and this is my modem. So for why it helps, I mean, it helps you for to understand the pattern, the flow. Is this a packet coming from the server or it is leaving my device? This is coming in, right? From a modem to my device. Because modem is your next hop, obviously. You won't see your actual MAC address. As I said yesterday, your actual packet, right? So if it is this is my modem and this is my computer, all I should see is this MAC address is here. Modem MAC address here as my source, and destination MAC is my PC. That is my Intel. So in your practical scenarios, you may see something like this, right? So you may see your firewall here. If it is a switch, I'm talking about this as a switch. This 192.168.0.135, if it is a switch, then it can be, this guy could be the switch now, and this guy can be a firewall or can be a load balancer, whatsoever. That's a logic. And since if you see this packet, I don't see any kind of VLAN information, .1 key information. Again, this is very important. Whenever even if you're dealing with your firewall, if it is a switch and this is your firewall, and you are doing this as a trunk, and Palo Alto supports trunk, but I don't know about other vendors, FortiGate and ASA. I think ASA supports trunk. So when you do a specific traffic flow on a particular VLAN, something like VLAN 10, I will show you the capture. Inside that you will actually see this .1 queue which says VLAN 10. So that's very important. So your actual packet is properly tagged with VLAN 10. That's something you can look into. This is how you can leverage your learning. When you learn, you don't think MAC address and IPs are not important. Most of the time when it deals with routing issues, it can be in the firewall or it can be in any device. Any device is doing a routing first, then it does your layer 7 inspection. So how you can leverage your Wireshark to troubleshoot this? So you have to focus on your source MAC, destination MAC, and your .1 queue. That's so important. And where it is coming from, that's something you should keep your eye on it. We'll do some captures and we'll understand that. Then coming back to the internet protocol, whenever we are looking into the internet protocol, is it IP version 4 or 6? Mostly inside the LAN, we'll be using IPv4. So you see your source address and the destination address, source IP and destination IP, and it shows your version and shows your header length. And here they are using the differentiated services. You don't want to, focus more on that, but there is some QoS packet marked with it. This is something you should be aware of. Identification, IP ID. If I drag this, if you want to, if I want this IP ID field should be added to my Wireshark profile, my default profile. All I have to do is I have to do a right click, apply as a column. You see this here. Here it shows the IP ID. So why it helps for me? Example, this packet starts with this client started with, look at here. It starts with 30242. This is the very first packet. So it incrementing by 1 every time. 42, 43, 44. This is a sequence of packet. That's something you can understand with that. See, 43244 and 245 packet is here. 46. So 42, 43, 44, 45, 46. It's like stamping out and sending all the packets, and all these packets belongs to the same stream. So this is a different stream. If you look at this, this is a different stream. Even though the IP is same, the streams are different. It starts with 49721. We don't see any other packet there. So this is whole new different conversation. So IP-AD helps you to do that, to find it, sorry. And this is not applicable outside LAN. Sometimes what happens here, you got your router and you got your switch here, right? So if you got a firewall or something, it may change your IP ID. So this helps very well for within the LAN. Within the LAN, I think no, I mean predominantly most devices they don't change the IP IDs. My understanding. The IP IDs are something when you do a ping. If I see 4 packets, if I'm missing one packet there, you can find out, okay, the third packet is missing with the help of IP ID. That helps. And you can apply as a filter if you want. If you want to remove this, you can remove this from the column. This is an IP ID in the layer 3 packets. Yeah. What else? Coloring rule, then those are the key options. So here, if you see the very first option is a source IP address. This is the destination IP address. Here in the protocol, you can see I'm doing an iperf. Sometimes it shows iperf. If you're using TCP-based application, it will show you the TCP-based application here. Then other key fields. You don't want to confuse much within the beginning. We'll talk about length and everything later. And the most important thing I would always say in the IP packet is your TTL. And you should know this. In the TTL, you have 3 different values based on your operating system. I think in Windows, let's see what is the value there. So you will see something 255, then 128, then 64. Your TTL always starts with these 3 values, mostly. What 255, 128, 64. So why it matters? So if I go to this packet, so what is this? It says from my source 192.168.0.135, I have sent out a packet to this destination, right? So from this packet, I have sent this packet to this destination 206.252.194.66. It shows iperf. That's fine. But what is the TTL I see? 128. So again, so when you look back, the packet coming from the public IP to my private IP address, your TTL has been decremented, correct? So what does it mean? So from 64, 48. Let me take this pen. You'll understand better. So how do I find how many hops away? Not only that, is it my packets are really routed? So if you subtract these two values, I think it's 14 minus 8, 6, 5, 4, 16 hops, right? So from my source to destination, I got 16 hops away. This particular destination is 16 hops away. Say, for example, if you do a trace route and if it is showing you 16 hops, so we'll do that. And I'll show you in Wireshark how to see that. So why this is so important? If your packet is not routed properly, if it is something, it should take 14 hops. But instead, if it is taking 16 hops, right away you can spot. And if you take a capture, if they say something is not working, it's an application or it's a routing problem, or it can be a protocol or something is blocking. Before that, you should see your TTL. So I am 16 hops away from my destination. So that's the meaning of this TTL. So how do I apply that TTL? So here I got in the IP header, right? If we come below this, if I expand this option, I'll see this time to leave, right click, apply as a column, and I'll get my TTL right over here. And it's based on your convenience. If I want this TTL to be somewhere here, I can keep, or I should keep somewhere here, I can keep. So usually I used to have all my IP options close by. Yeah. Then we'll come to the sequence number and acknowledgement. But mostly you need this options. And when you are dealing with TCP, I would say you should add your sequence number option here. If you see this as sequence number. And one more thing, don't prefer your relative sequence number. Sorry, don't choose your raw sequence number. So Wireshark helps you to organize the sequence number on its own way. That's something we use most of the time. That's very easy to follow because the raw sequence number is bigger and very hard to analyze. So here in the sequence number, I did right click. Yeah, right below this TCP option, right? So if I expand this option, I have to choose only my sequence number option, not a raw sequence. So I have to do a right click, apply as a column. Already exists as SQN. Yeah, already I did that. So fine. So what else you can do? One more thing. I think where is that? There is an option to edit a column. Okay. So here the sequence number, it's a pretty big name. So I don't want that. So I want to make it short. I will make it as SQN. You can give a title right over there. And if you click OK, you can change your name. For example, if I go here, edit column, and if I want to change to anything, acknowledgement, it will change like that. So I'm going to make it as ACK. And always keep SYN and ACK close by. That helps you to track your packets in the future also. Then what else? If you want to apply a packet for a specific IP address like this, and you can either give this arrow mark, so it processes your packet, or you can just simply press enter on it. Then if you feel sometimes you want to zoom this, you can use zoom option. This is zoom out. Then if you are capturing your packet and if you suddenly you want to do a quick analysis, I mean, is it my TCP connection is happening properly, and how many endpoints are going through in a particular device? It can be a firewall or a switch or a router. You can, if you do an endpoints, you will see all kind of traffic, right from your IPv4, IPv6, your TCP. So there are 16 columns here and 204 TCP connections and 13 UDP connections. And in the Ethernet, you see the number of packets it sends. So, but I would say this is not the best way to see. Here you can see what is actually going on in your network. And also, if you want to apply a specific filter for it, click on this particular packet. I'm interested only on this IP, or maybe if I'm interested on the public IP here, total bytes is 278 bytes of data. And if I want to limit this capture, so it just shows me the capture only for this particular public IP address. It limits your capture. The option is here in the left-hand side. But I will always use this option if I go to statistics and if you go to conversations. So this will give you a 4-tuple connection. Source IP, source port, destination IP, destination port, and the number of packets. But sometimes if you see a burst in your packet flow, how many packets is being sent, you can see there's a 3 meg of data has been exchanged so far. And you can also see the stream ID. So from source to destination, client to server, you send 171 packets here. This is from B to A, from server to client. It's all something you will get some good amount of data, whatever you want. And if you want to follow the stream right away, you can do a stream and you can see that right over here. It's all encrypted. We can't see anything. So we'll see this in detail, how the stream works in the future class. Here we are just discussing about the most important filters, what we use here. If you see this TCP stream equal 171. If I remove this, it's going to show me the whole capture. The total is 21,273 bytes of data. And if you want to save this file, save as, and wherever you want to save, you can save this. In your hard drive or in specific folder, you can save this. And always save as a PCAP file. Wireshark will have the default option. If not, you have to save this as a PCAP file. So only then, if you save it as a PCAP file, only then you can open and read this packets. Or else you can't do it. What else? That's it really for now. In the future, when we do an SSL encryption decryption, I'll show you there is some options we have to use. But these are the most important options you may use. And I'll tell you, I mean, what is sequence number, acknowledgement number? This is all the how you design, and you should be a bit comfortable with Wireshark tool and what are the options you should see and you should concentrate. So that's it about this layout. Let me open this. So I gave unmute permission. So far, whatever we discussed, if you have any questions, you can ask me.
Can you show that time function that previously you showed? Time and TTL.
What is that? What do you want me to show?
Can you show that where we have to select the time function, time functionality?
1 minute. View time format second since previously displayed packet. Yeah.
Okay. How you reduce this TTL value? Like you're given some TTL value. So you get
Sorry.
some based on which you did that TTL calculation. So in this capture, it is shown 128.
Okay.
So where you did the calculation?
No configuration. I mean, it's in the layer 3 header. Here you got your TTL. I'll have to do a right click and apply as a filter. Selected and it will go up here as a column here. Yeah.
You talked about like it is this many hops behind that calculation. How you did some
I think you can watch the video because that would be a repetition again.
okay.
Yeah. So this is 57. If you take this 57, it's from what is the value for 64 from 57?
Okay.
How many
From
numbers you would add? You tell me, I mean, how many numbers you would add to get 64 here?
okay. Like that you have to calculate. Okay.
7 hops away. Between this destination and this source, we got 7 hops away.
Okay. From length minus time.
No. It's very simple. 64 minus 57 is your number of hops.
Okay. No,
Because you mm,
where you
yeah.
conclude the 64?
I didn't do that. I mean, it's as I said, it's defined by the operating system. If you see, there are some values it starts with 128, and here it started with 57. So it depends because this particular host, I don't know, it can be a Linux or it can be a router, I don't know. So the three values are 128, 255, and 64. That's the starting value of the TTL for the particular machine.
Okay.
And it decrements. So when it decrements, it means that the packet is routed.
Okay, got it.
Yeah. Okay. Any other questions, guys, about the filters?
Hi, Praveen. This is
Uh,
Nilesh.
Hi, Neelish. Yeah.
Yeah, talking about the layer 2 frame. Okay,
Mhm.
if I want to see the jumbo packet, then
If
how?
you want to see the jumbo packet,
Yeah,
MTU.
yeah, yes. MTU. As per MTU, I can see that packet. Is it jumbo or not? Correct?
Yeah, we will come to that. Yeah, we haven't started that. Yeah, I'll show you, but not by today. Maybe if we have a
Okay.
time, yeah, or else in the next class. Yeah, because we have a lot more to cover in the layer 2 and layer 3.
Okay. Thanks.
I'll show you that. Yeah.
Uh, Hi, Praveen. Actually, I want to know about the endpoint details. You told us earlier endpoint. So how is the actually the configuration in scenario of the DC and the DR scenarios? Because in the DC and the DR scenarios, there are the n numbers of the hopes are there. Then how we can conform to develop this tool?
No, I didn't get your question, Vithal. What is the question?
Uh, my question is, for example, source and the destinations are majorly traffic is traveling from DC to DR. Okay,
What is DC to DR?
This is the data centers and the data centers recoveries, disaster recoveries.
Okay.
So the traffic is from here to there. Okay, so lots of the
From where? No, from where to where?
source to destination in between.
I mean, source is your data center, and destination is
Yeah.
your DR. Okay.
Yeah. And the in between, n numbers of the routers, firewalls, and another means L2 switches are there sometimes. L3
Mm-hmm.
routers or firewalls. Again, destinations and also the L2, L3 devices are there. Firewall,
Mm-hmm.
LBs are all those
Mm-hmm.
things are comes in the picture. So
Okay.
how we identify help of this that endpoint option?
Endpoint is not related to that. The TTL is the one you have to look into when you want to find the number of hops. Endpoint will give you what do you say, historical data. I mean, how much data has been sent and how many source and destinations are involved from the endpoint where you're capturing your traffic. I'm doing from host, but mostly we do that from the switches or firewalls, right? So there you see your traffic for the a complete historical data from the firewall, how many packets are going in, out, like your monitor logs in Palo Alto.
Okay.
What's your question is to find the number of hops is something you have to look into your time to leave, where you can find your number of hops.
Okay. What is the TTL value is need to check, right? TTL.
Yeah, TTL is a number of hops, yes. And I mean, if it is a layer 2 devices connected in the middle, TTL will not come into the picture, right? It's only for the router devices, like your whatever the devices in the middle, it does a routing. It should be capable of layer 3 device. The layer 2 device, there is no TTL in layer 2. That's why you see loops in the layer 2 a lot compared to layer 3.
So in this case, is there any L2s has issues? Then how to identify? Is there any idea? Any clue?
Layer 2 device, what kind of issues is layer 2 is doing? Example, what you suspect a layer 2 device is
Yes.
doing?
Yes, sometimes what is happening there, L2 device are the ports are the flapping CRC errors, and sometimes VLANs are misconfigured, or n numbers of the reasons are beyond of that.
Then
So
you
how,
have to look for your spanning tree. Spanning tree is something you have to focus on. How many TCN packets, topology change notifications you see? You see a bulk of TCN packets triggered, then it should not be, right? So if there is one changes, and that's not very frequently you do changes in the switches. So if you see a TCN flood, then your L2 is not stable. You have a loop. That's something you have to check your TCN packets.
okay. And one more question is from my end. How to check the IPv6 traffics also, means the DNS traffic we check and all those things. And how to we check with the IPv6?
IPv6, yeah, I will tell you. I mean, not now. Yeah, maybe we will cover that. How do we see the IPv4 packets? Yeah.
Okay, okay, okay. Thank you so much. Yeah.
Yeah, sure, no problem. Any other questions?
Praveen, could you please show us that last points which you show us? It is related to packet name. How I can assign that packet name? Like
I mean, okay, this you're talking about this. I mean, example. Okay, if I go to edit column,
edit
if I
column.
do
Okay.
edit column, so I can type something. The name, that's a title. I can give whatever I want. So if I do a TTL, it changes to TTL instead of time to leave, because that minimizes my layout, right? Because if it is bigger and bigger, then I can't see much more details because it's very small keyword TTL.
Okay, got it. Yeah, thanks.
No problem. Any questions, or we will jump back to the topic? Okay, fine. So again, I will go on. I'll mute you guys. Once I finish it, we'll come back to the Q&A. So now here, today we'll talk about this TTL practically, and before that, the key options. Let's compare. I mean, what we discussed, and is it something we are missing still in the IP header? So today we saw this identification. We will do a lab now to see this identification number, then the version and the type of service. As I showed, that is a QoS. We are not focusing much on QoS, but if there is any latency related problem, I would suggest even if you are not doing any analysis related to the QoS, differentiated services, right? DF bits, you can at least ask them. I see even the packets coming into the firewall, and I see this QoS packets. Is it something your QoS is something doing, or maybe you have to look into your QoS? You can talk to your network team if you are working from security, and if you are doing, and again, if you take care of your routing and switching, you can also check, is it what kind of marking is that? Is it you're doing any kind of priority based routing using this your QoS? And source destination IP options we will see in the next class. Then IP flags and fragment offsets is something I will show you now how to see that. And on top of that, we got something like a layer 2 and layer 3 MTU. That's very important. So I'll give a quick diagrammatical representation for it, so you will understand that better. So whatever questions you have about this, you guys can make a note of it and ask me in the end of session Q&A. So I'm going bit slow because it's the beginning of the class. So once we are comfortable, when we are fundamentally strong, then I'll go a little fast. Yeah. So this is a router, and it can be a switch. I don't know about the firewalls. Actually, I didn't play much with MTU on the firewalls. Let's take this as a Palo Alto firewall. That is a layer 3 device. I think you have an option to change it for sure. So the MTU is a maximum transmission unit. We say that that's very important. We know it's configured in every interface, right? Let's take this a different color that stands out better. In every interfaces, you configure your MTUs. So the maximum bytes allowed is 1500. If somebody is asking you, my layer 3 MTU can be a jumbo frame, like 9300 example, and 9000, you can say 9000. Can be, I can change a layer 3 MTU as 9000, or can I change a layer 2 MTU as 9000? So when I say layer 2 MTU, that is Ethernet MTU. When I say layer 3 MTU, that is IP MTU. So whatever the changes you do, the jumbo frames, that is only supported in the layer 2 MTU. So when you go for Nexus or some kind of platforms, you do this jumbo frame configuration, that is layer 2 MTU. And why are we discussing this here? Is it so important? Yeah, definitely. If you have a problem, a slowness generally, and if you are experiencing some kind of slowness, mostly sometimes what happens, the Nexus device, it keeps pushing your data in a very high speed, because your layer 2 MTU can be 9000, right? I'm trying to simulate this in my lab, and I'll get back to you about that. But today we will see the layer 2 and layer 3 MTU, but not the jumbo frame MTU. That's something in the next class I am trying to come up with. So we should understand this MTU. So if my MTU size is 1500, and that's something you can configure and you can change. And if I keep an MTU in a different size, do you still have a communication? Yes. But what happens here? If I send the 1500s of data, it can't process it because this packet size is 100 bytes, or I mean, this 100 bytes of data is lesser than the source. So what happens here? It does a fragmentation. Who does a fragmentation? This guy, because this guy is going to send 1500 bytes of data, but it does a fragmentation. So it processes 1400 bytes first, then the remaining 100 bytes of data. So inside the router, if you go and check, you can see those fragmented packets. Okay, I'm working on this, so I'll show you this exact values where to find. Yeah, today I just want to give you the understanding of this MTUs. So in MTU, when you talk about MTU, we should know about these two MTUs. There is called Ethernet MTU and the layer 3 MTU. And I think I got some slides for it. So here, this particular box has an MTU of 1400. And if I do a ping for 1500, without fragmentation, what happens? You will get an error, correct? Let me demonstrate that. But have you found that this is how you configure your MTUs? Now, just first, let's do a common discovery. I mean, how this MTU works. I'll show you that. Then we'll come back to the actual lab. We will do that and you'll understand that MTU. So what I'm going to use, this is a Windows command. I'm going to ping -f means do not fragment. DF, don't fragment. I'm telling without fragmentation, I'm going to send this 1472 bytes of data. And my destination would be Google 8.8.8. So what happens here and how this can be used for your troubleshooting? When you have your problem is slowness or something, and you see a lot of fragmentations, right? Because every time it has to do a fragmentation, it is a more compute related task. So the hardware has to do a lot of compute to process those data. I think, let me quickly do this. Okay. Let me erase this. So when I ping, yeah, to the Google, I'm telling don't fragment for the DNS. The length is 1472 bytes of data. If I press enter, packets need to be fragmented. So how do we see that in the Wireshark? I'm going to my Wireshark, going to use my Wi-Fi adapter. The packets are dumped here. Now again, I'm doing for, see, the filter what I'm applying here is for IP.address 8.8.8. Only that. 8.8.8.8. Oh my God, what is that? Wireshark got freezed. Waiting for it. Okay. One minute, I'm just looking into this. I think it got freezed or it's not capturing any traffic here. I'm seeing a ping. I see P. DNS matches Google. Why I can't see any traffic for it. I'm going to start this again. CMP. Okay, can see that now. So look at this. Let me take my pen. Still it is running. Okay. If you see here, it says the code for fragmentation is needed. But what we did, see, there's an ICMP error. So what we did here, we said that you should not fragment. And the ping, I'm pinging it. So it means that the size of the MTU for the Google DNS, right? So I'm sending this, and remember, it can't be directly to the destination. We will come back to that. We'll do a lab for the path discovery MTU. This is along the path, there is something, the MTU size is different. Example, if you go back to this, you will understand this better. See, maybe my MTU can be 1500 for my next hop, but in the third hop, it can be 1400. I don't know. And I'll tell you hop by hop, how do I find the MTU. Then you can exactly go ahead and figure out where the problem is. Now, first, we have to first we are trying to learn what is MTU and how it works, what is fragmentation, what is the length, and all the basics. That's important. Then we'll go for the advanced troubleshooting of MTU in the next class. So here, if I give, then I'm doing an analysis. Okay, 1472 is bigger packet. So if I do now, what happens here? So now it says that 1400 plus 42 bytes of additional header values. It's added. So the actual payload of the packet is 1400 bytes of data. So now I don't see any errors. But if you see here, I see an error and it says fragmentation is needed. So this is a payload, what we send. This is the length of the packet. If you see this length is 1500 something, we drag here. So payload is your length of that particular layer. And this is a ping reply. And if you look at this, what is the key value you should look at here? The flags. Is that one more? We lost that one more. Let me stop this capture. You can see the class selector here we are using some differentiated services bits. And where is that error packet? I'm trying to figure out. Okay, this is the error packet. Okay. So here we need a fragmentation. That's something it shows. And the MTU size, if you do a calculation, if it is a bigger MTU, you can tweak your values and you can figure out how this MTU works here. So if I am using without this, I don't want to, now I'm not telling that don't fragment, right? Don't fragment bit is not set. So now the router, if I do 1600 bytes of data to this guy, what happens here? The request time now. What if I do 1500? What if I use 1450? It works. Why? Can have your questions noted in the Q&A. I will tell you why. So in the IP header, if you look at this in the IP header, you can't use your complete payload, data payload for 1500. Let me take this pen. You can't use the complete 1500 bytes of data because you got your source address, you got your destination address. These are all the header values you have. Right? For every header, there is a value. So example, in the source address, it's the 32-bit addressing. So you need 32-bit address space for this. So all together is 1500. So I can't use the complete 1500 only for data. Even if you see this capture, it is sending 1442 bytes, not 1500 bytes of data. So the rest, we would say the 100 bytes of data is used for other header values for your source address 32 bits, destination 32 bits. If you're using IP options altogether. So that's something you should understand why you see a different value there. So when I'm pushing this data without fragmentation, it is not allowed. I can't do that. In one go, I can't send your data right away like that. So what happens, whatever the data you send, it is fragmented and right away you can't send this 1500 directly. Here it is an ICMP we are tweaking, but the application is designed in such a way it can't send the 1500 bytes of data together in one go because you should give some space even for the other headers. So let's do this in the lab now. Let's do this in the MTU configuration and we just do this lab and we'll finish this. So for that, let me go to the terminal. I'm going to the switch. So IP interface brief. In the switch, I'm going to this interface, directly connected interface GI 0/3. So this MTU, if you see the value, it goes from 64 to 96,800. So this is called Ethernet MTU. So there are two MTUs, as I said, you have two different MTUs, right? So where is the pen? So this value can go, this Ethernet MTU, if I say this Ethernet MTU, that's for layer 2 MTU, it can go, this MTU can go up to 9600 bytes of data. If you're using some Nexus, there are two options, right? You have your jumbo frame and your super jumbo frame. So mostly they use jumbo frames, not the super jumbo frames. So here, how do I change this MTU here? So I'm going to give a value but before that, how do I check my MTU? Show interface. This is to check your layer 2 MTU. Include MTU. So the layer 2 MTU is 1500 bytes. And always the Ethernet MTU can be higher. than the layer 3 MTU, but layer 3 MTU cannot be higher than layer 2 MTU. Show IP interface include MTU. Show IP interface. Let me check for one specific interface. GI0/3. GI1/3. Why it's showing something like this? Switchboard access VLAN 10. Okay. Interface. Okay, no problem. We'll change this value and let's see what is the reflection it takes. Interface GI 0/3 IPMTU. Oh, I should give no switch port. Okay, that's why we don't see that. Okay. So I mean, in the switch ports, you can't do it. It should be a routed ports only, then your layer 3 MTU works. Yeah. So here, if you say MTU, now I can change a value something like 1550 to differentiate. If I say IP MTU, 1400. So I changed layer 2 MTU and layer 3 MTU. GI 0/3. So MTU is 1550. This is a layer 2 MTU. You guys can still see my screen, right? If you can't, let me know. Ping me if you guys can't see my screen. Okay, you can't see, okay. Your entire screen. I think now you can see my screen, yeah? Show IP interface GIs. Now visible, okay. Internet protocol processing disable. That. What interface is that? GI 0/3. Okay. So the layer 2 MTU is 1550 bytes of data, and this is something I configure to 1400. So I can assign an IP address now. So let me try to establish a connection back between this Kali Linux and this guy. We go to Kali Linux and what is the IP address of it? Yes, config 10005. Right. So I'm going to make this as a point-to-point connection now. I'm going to assign 10001 on this guy. Configure interface. IP address 10.0.0. I think I got some VLANs here, so I have to remove my VLANs. Interface brief, exclude unassigned. Config, no interface, VLAN 10. Now go to my interface GA0/0, sorry, 0/3, IP address 10.0.0.10, 255.255.255.0. No shut. Oh, I got my the OS rebooted here. Come on, show IP interface brief. Interface G0/3, IP MTU, no switchboard. PMTU, the maximum size is 1500, so I'll make it 1400. Then MTU. 1 minute, let me share my screen again. I got a little power cut here, so let me share my bigger screen. Okay. So now my MTU layer 2 MTU is 1600 bytes. And I'm going to assign an IP address interface GI0/3, IP address 10.0.0.20, random IP address, a point-to-point connection. 55.255.50. No shut. OEP interface brief, exclude unassigned. Up, show IP auth, ping 10.0.0.5. Okay, let's see if we can take a capture here. 0/3. I'm on the switch. I'm trying to take a capture on this particular interface, GI0/3. Okay, so no worries. We'll take a capture from. We'll take a capture from this Kali Linux box. Go to terminal, go to Kali Linux. Let me make it bigger. Let me take a Wireshark capture from this. So this is a connection goes to the switch. I can't see any packets going in. Okay, it's a bit slow. Ping. Okay. Let me take, okay, from here I'm sending some traffic and I can see it. MTU is this. Let me go and check the interfaces. My layer one is all fine. Want to check few things, I'll let you know. IP interface brief. Oh, interface GI0/3. Okay, so now let's take this VOEOS box, this box. So I'll configure this GI0/2 for a different MTU and we'll ping across and we'll see what is the output we get for it. An MTU testing we will do. We'll try to simulate that traffic there. I want to ping across with the different MTU and I want to show you the outputs, how it looks, and how do we troubleshoot when there is a problem with MTUs. Go for this GI0/0. IP address. I'm not going to do any changes here. Default value is 1500. So I'm going to assign an IP address. Before that, let me quickly check the config. So IP interface, brief, exclude unassigned. 20002. Okay, so let me first save the config times reboots. So CDP neighbor, let me see the switch is GI0/2 and it goes to 1/0/2. So this particular interface I have to configure it's GI0/0 here. Okay. $20,002 in the switch. Okay. I got 20002 and I want to configure on GI0/2 here. Yep. This interface GI0/0 is configured for 20002. So I want to make the same IP subnet here to establish just a point-to-point connection between them. 0/2. IP address. No switch port. IP address 2000. Come on. 90, 255, 255, 255.0. Sure. So IP interface brief load site 90. Okay. So this is GI0/3. If I try to ping GI0/3 from this guy. So is it a default route for 20 network I'm going? I don't know about 10 network. So my switch, what is the next hop for me? It's 200090. So I'm going to this device and I'm telling IP route if I want to go to the 10 network. Yeah. Here, I want to do a testing on this because this interface GA0/3 is connected and it is configured for 10 network, and I did some MTU changes and I want to test across. So if I want to reach this network, this device doesn't have a route to it. Sorry. So I'm going to do a route, static route for it. 255, 255, 255, 0. So my next hop would be 200090. 200090. So for the 10, my next hop is 20. Okay, ping 10005. Okay. I can do a ping 100020, and if I do show IP interface brief, I got two exit interface. One is 20 and one is this guy 0/1. 00/2 is for 90. Okay, so apparently it should come from this. Okay. So if I do a ping to same IP address, just if I want to do for this testing, I'm just going to do a ping. But I'm just thinking my Wireshark is not working here, and how do I take a capture of it? Sorry for that. I mean, my Wireshark is not working, so I'm going to configure something here, this interface. Think here we okay. At least in output we can see. I'll fix the Wireshark next time. In this lab, this interfaces. If I do a ping to this guy 100020, there I have tweaked my MTU. Oh my god, it's what is that? Ping IP, target IP, repeat count 5. Datagram I am giving this is an IP MTU testing, yeah. So I'm giving 1600. But we configured there as a 1400. See this show run interface EI0/3. IPMTU configured as 1400, but purposely I'm increasing the size to 1600. Extended command, yes. Source interface GI0/0. This interface GI0/0 that is assigned with 20002. Type of service, I'm not using any QoS policies here. Set DF bit, do not fragment bit. Yes, I'm telling don't fragment and send the data as it is. I want to send the whole 1600 bytes of data. Yes. This verbose will give you, I mean, the detailed output of it. Sweep range, I will give from 1400. So it's a request timed out. The packet is not sent because I said that I'm telling don't fragment this particular device. It should not do a fragmentation. I want to send the whole 1600 bytes of data. My datagram is 1600. What if I reduce the size? So this is the destination 100020. Datagram, if I'll give 1200. Extended command, yes. Source address identified. So I'm telling set DF bit in the IP header. No. Yes. And other things, let me keep it default. So now I can ping. So if I say do not fragment, and if I want to send the whole data as 1600 bytes, so it's not allowed, right? So the MTU is that, I mean, whatever the data you push, but the actual device, it does a fragmentation. That's how the whole networks are connected. That's how your MTU plays a vital role. I'll fix the Wireshark capture next time here, and I'll show you some more outputs about related to this MTU there. Yep, there is some problem with this. I can't do a capture. I don't know, suddenly it stopped working. It's not happening now. Capture GI0 slice. Okay, so let's fix this in the next class for sure, and I'll show you those outputs there in the lab as well. We have seen that practically there, but anyway, in the lab also I want to show you. It's fine. Let me stop sharing. Let me stop recording. Okay, I gave an unmute permissions for everyone, so you guys can ask me questions.
Praveen, I actually yesterday's RF broadcast
What
and the cast, how to traffic check that point was pending actually.
what is that? Sorry?
RF broadcast and the unicast.
Or broadcast and the unicast. Okay. I mean
Nilesh was asked
that's
that question. Yeah, Nilesh was asked that question. So
uh-huh.
I'm
What what
also
what what is that question? Can you repeat? Bit slow because I can't follow you. Can you be a bit slow and ask your question?
in the R actually broadcast and the unicast two messages are there, na?
Uh-huh.
So what
Yeah.
is that actually? That was actually looking.
No, still I am really sorry. What is that? Can you repeat it in the R broadcast and unicast? What you are looking for?
Unicast is there, right? In the R broadcast and the unicast.
Yeah,
So that how to check that the traffic in Wireshark?
we did that yesterday, right?
No, actually we missing yesterday.
No, I remember that I have shown the unicast and
No,
broadcast packets
no,
there.
no. Nilesh was asking you, but you told him yesterday we will check it tomorrow. So I was also waiting for that.
No. What question is that? I didn't get you. Yesterday, I shown you the ARP request is a broadcast and ARP reply is a unicast, and I have shown you the headers and the IP values there, right? So in the unicast, it sends back to the same source because when it is doing a request, the request packets goes from the source. So it sends a source MAC address and the sender IP address there. Once the receiver receives it, he sends a reply back to the same source because he knows where this ARP request came from based on the source IP address and source MAC address. I remember that I have explained this yesterday. Maybe I would say you can go back and watch the recording again. Yeah.
Okay.
Any other questions?
Sir, today we have seen that you have configured two MTUs, right? One is
Yeah.
MTU directly on the
Yeah.
interface, another one is IP MTU.
Yeah.
So
That's
both
right.
the MTUs are different values. So when
Yeah.
the packet arrives,
Hmm.
how it will impact, I mean, how it will behave, which MTU by default it will take in order to process the packet.
Which MTU it takes from the layer 2, whatever we configured there, that's going to
Mhm.
in the layer 2 MTU, there is no fragmentation.
Okay.
The fragmentation happens only in the layer 3. Even if you see that if we do a ICMP ping with a larger MTU values from my computer, the fragmentation happens only on the layer 3. It doesn't happen in the layer 2. So in the layer 2 MTU, nothing happens. I mean, whatever you are giving, the jumbo frames, if you still send, the higher jumbo frames is preferred. But when it goes to the layer 3, based on the MTU value, it does the fragmentation. Example, you are pushing a jumbo frame packet of 9,000 bytes of data. When it goes to the layer 3, it fragments the data. It can't process the jumbo frame directly from the layer 2. So what happens in the layer 3, it does the fragmentation. And then we have a lab for the fragmentation. So there you will understand. But no fragmentation in layer 2. So when it goes to the layer 3, because the layer 3 has a lower MTU value, so the packet will be fragmented.
Okay, sir. So, yeah, please go ahead.
Yeah, that's it. I mean, I've shown you the output. In the output, when I do for 1,500 or 1,600, whatever the values it's given above, I mean, we gave 1,400 bytes in the layer 3 MTU for the switch on the particular interface. If you try to increase more than 1,400 bytes, and if I set do not fragment means I am telling don't fragment and try to process this data, we see request timed out. But if we don't set the do not fragment, it means that, okay, that's fine. I am sending 1,600 of bytes of data. You can fragment the data, but anyhow, you have to process your data. Then it is okay with that, and it is fragmenting, and you get a ping response back successfully.
Okay. So let's say our layer 2 MTU size is 1500, which is by default. And we are sending the jumbo frames. Still, it will accept the packet, right? As a layer 2.
So one side, if it is 1,500, if it doesn't have a capability of doing it, then your interface will not come up. Both end has to be properly configured, your layer 2 MTU.
Okay. Okay. So if it's a jumbo frame, let's say 9,000 bytes, on another side also, it has to be 9,000 bytes.
Yeah. If you remember, if I have experienced this maybe 5-6 years back when I worked in a project, if you are connecting a server and if it should support the jumbo frame, even the NIC and the capability of the NIC should support the jumbo frame. It can't be a normal MTU there, because there is no fragmentation in layer 2.
Correct. Correct. Understood, sir. Thank you.
Yeah, no problem. Yeah. Any other questions related to today's topic? I'll come back to the Wireshark. I'll fix the Wireshark. I don't know, something happening behind in this lab topology.
Praveen, this is hello. Praveen, can you hear me?
Yeah, I can hear you, Setu. Yeah.
Okay, when it comes to point-to-point protocols, is layer 2 fragmentation is going to occur?
In layer 2, fragmentation will never happen. Only in the layer 3 it happens. In a point-to-point connection is a layer 3, not a layer 2.
MPLS?
I don't know about, is it the MPLS we say point-to-point? I am not very expert in MPLS, so I am not really sure about MPLS point-to-point, but we say only the, what is that? Point-to-point connection between the devices is mostly layer 3 I have seen. VPLS is something I don't know how it works in VPLS. Your voice is going low and high. I mean, it's not constant, loud, not very loud and clear constantly. No problem. Yeah, you can
How
adjust
about
your mic.
the Wi-Fi for 802.1x networks? Is fragmentation is going to occur at layer 2 for Wi-Fi networks, or no fragmentation there? Or fragmentation is applicable only for layer 3?
Fragmentation is applicable only for layer 3.
Okay.
Layer 3 mechanism does the fragmentation. We'll have a lab. I mean, I'll show you how this it fragments the data with output.
Hi, Praveen. Sumit this side.
Yeah, hi Sumit. Yeah.
Praveen, you were saying the fragmentation sometimes causes, the MTU, if it is not configured properly, sometimes causes the slowness, right, in the network.
Yeah, if you are pushing large amount of data and if the MTU size is smaller there, I mean, along your path, then yeah, definitely it impacts
So
your
let's say
performance.
from source to the destination, we have a couple of firewalls, L3 devices. Okay. Now with the Windows ping command along with the MTU size -L -F -L, the command which you use to ping the destination IP along with the MTU size. We are pinging it, and we want to trace where exactly the MTU is mismatched in the network.
There, I think
How will you do
you
that?
have a is it a trace path in Linux? I think you can use to find hop by hop MTU. Even I did that. I'll come up with that. I mean,
I
today I
mean,
didn't
hop
get a
by hop.
software.
I mean, we cannot do it from end to end, or we have to do hop by hop. I mean, each hop we have to go separately and ping. Is it like that?
No. It's like I think it is an M trace. I think I'll come up with that in the next class for sure, because I remember this, but I want to show this. That is something we say PMTU. It's a path discovery MTU. So when I had a problem with the Wi-Fi connections across the path, there was something, a PMTU misconfiguration happened. I think I used mtrace or some output. I think that gives me, if I do a trace route, it by hop, it will show me what is the MTU configured on the devices along the path. If it takes 10 hops, it will show for 10 hops what is the MTU has been configured there. I think trace path you can try, and I'll also try. I'll come up with that. I have to do little research on that. I'll come up with the
Trace paths will always work, but that is for IP always, but not with for MTU, right?
trace path is used for what? That's the whole thing is it's used for to find the MTU, right? I don't know what I didn't use much, but I think it is the purpose of trace path is to find your MTU. I'm correct?
But
Not
trace
your.
path is used to find the destination
Okay.
along with the each hops. I mean, what hop it is following.
No, you are talking about trace route. I am talking about trace path. Trace route is
Okay.
different. Trace path is different. I think it is trace
No,
path,
actually
I think.
the both are the same. That is the difference is only in the firewall and the routers. We are using the trace route, and then Unix and other devices we are using the trace this
Right.
trace path.
And actually, it varies with the platform. Praveen. I mean, I think on Windows you can use trace RT, or somewhere you can use trace path, and somewhere you can use trace route, something like that.
Correct.
Not really. 1 minute. Let me.
I think the both are the same.
I don't think so. 1 minute. Let me share my screen. But I have to do some experiments with it. But I did that in Windows, I remember. But the tool, something it was not working today. If you look at this, I think this output, what they have given here, it shows me the path MTU values, right? Path MTU 114, 1492 is the value of MTU values I see here. I'll do some proper, research on this and come back to you. But Linux, I don't know how far we can run Linux, but in Windows, I definitely have it. I'll come up, I'll come up with the software in the next class. Show you this. Any questions? I'll make note of this question. Yep, the path MTU. I'll come up with that. Any other questions? So we are good today. No further questions. We can wrap up this call. Okay. Okay, so try your labs. Is it Nilesh, you want to talk something?
Yes, Praveen. When we'll see this recording in our portal?
I think by
Could you
hopefully,
please?
hopefully today, or maybe I think tomorrow. Usually they do it in the first half
Okay.
before afternoon. I think. Yeah.
Thanks,
Uh,
Praveen. Have a nice-
Yeah,
Praveen, when will you provide the labs files and all?
I will send today or tomorrow. Give me time until tomorrow afternoon. Yeah.
Yeah, please. Okay. Thank you.
Yeah, sure. Okay, guys, then have a good day. We'll see you in the next class.